Before we do some alkene nomenclature, let's take a look at two famous alkenes. So over here on the left, we have our limonene. So the ene ending gives away the fact that limonene contains double bonds in it. So our limonene smells like oranges. So it's the molecule that gives oranges its smell. So even if you've never heard of the limonene molecule, you've definitely smelled it before. Over here on the right, we have another alkene called alpha-pinene. So again, the ene ending tells you that there's an alkene or a double bond present in the molecule. Alpha-pinene is one of the main constituents of turpentine, which most people know is a solvent used in oil painting. And some people think that turpentine has a bad smell to it, and that's incorrect. There are definitely some bad forms of turpentine, but if you get some high-quality turpentine, alpha-pinene has a very, very nice smell. So limonene and alpha-pinene, two molecules with great smells to them. Let's take a look at some simpler alkenes and see if we can name them. All right, so if I were to look at an alkene, it looks like this. Let's go like that and put our double bond right here. And how would I name this according to IUPAC nomenclature? Well, when we named our alkanes, the first thing we did was we found the longest carbon chain. And we're going to do the same thing for alkenes, except this time we're going to find the longest carbon chain that includes our double bond. So the longest carbon chain that includes our double bond. Well, you could go like this. So that would be the longest carbon chain including our double bond. And how many carbons is that? 1, 2, 3, 4, 5, 6. So 6 total carbons. When we were naming alkanes, we called a 6-carbon alkane, we called that hexane. Obviously, we can no longer use that name. We do have 6 carbons, but we have a double bond present in the molecule. So it is an alkene, it is not an alkane. And we've just seen how the ene ending is used to identify alkenes. So instead of an ane ending for an alkane, we're going to use an ene ending. So instead of hexane, we're going to call this hexene. When I go to my next step, I need to number my carbon chain. And I'm going to number it to give the double bond the lowest number possible. So I have two options. I could start from this carbon up here at the right, on the top right. I could make that carbon number 1, or I could start down here with this carbon at the bottom. I could make that carbon number 1. You want to give your double bond the lowest number possible. So I'm going to start with the carbon at the top right being carbon 1. So if this is carbon 1, this must be carbon 2, this must be carbon 3, 4, 5, and 6. So my double bond starts at carbon 2, so I'm going to go ahead and put a 2 in front of this and make it 2-hexene. So it's implied that the carbon that the double bond finishes at the next carbon. So the double bond spans the distance between carbon 2 and carbon 3. So I have 2-hexene here. So let's go ahead and finish naming this. I have to worry about my substituents. I have 2 methyl groups at carbons 4 and 5. So I could go ahead and name this 4,5 dimethyl, and then I have the 2-hexene like that. So that is an acceptable IUPAC way of naming, although this is kind of an old school way of naming, and since I was taught by an old school professor, this is the way that I've always done it. So 4,5 dimethyl 2-hexene. The other way of doing it would be to write 4,5 dimethyl, and then write hex, and then put the 2 between the hex and the ene. So hex 2-ene is another way of writing it, and this is the way that recent IUPAC recommendations say to do it. So 4,5-dimethyl hex 2-ene is the more recent way of naming it. 4,5-dimethyl 2-hexene is the older way of naming it. For most professors, both ways are acceptable, but make sure to double check with your professor. All right, let's name another alkene. This time we'll talk about an alkene that's in a ring. So let's look at a molecule that looks like this. So let's go ahead and name that. Okay, well, find my longest carbon chain. In this case, it's a ring, right? So how many carbons are in this ring? There are 6 carbons in this ring. So a 6-carbon ring alkane would be cyclohexane. But since there's a double bond present in this molecule, we are going to call it cyclohexene. So I have cyclohexene. Okay, next thing we need to do is to number this molecule. So let's see, what could I do to number this molecule? Well, I could make this carbon number 1, or I could make this carbon number 1. And let's go ahead and draw this molecule again, and let's name it those two different ways and see which one is the correct way to name this molecule. So let's start, let's say on the left, let's make this carbon number 1 on the left. So if I make that carbon number 1, let's go ahead and put a color on it. So if I make this carbon number 1, then that implies that the double bond starts at 1 and then finishes at 2. So this must be carbon 2 right here. And that makes this carbon 3 over here like that. On the right, I'm going to make this carbon number 1. So if this is carbon number 1, I have to go in the direction of the double bonds. So I have to make this carbon number 2. And to get to that methyl group, I have to go all the way around like that. So you can see the way on the left gives me a methyl group at 3, and the way on the right gives me a methyl group at 6. So the way on the right is not the proper way to number your ring. The way on the left is the correct way to do it. So the official name, we can go ahead and put 3-methyl cyclohexene, like that. Alright, what about some substituents containing double bonds? So what about if you had something like this coming off of your molecule? So we'll put a little funny line there to indicate this is coming off of a molecule. This is called a vinyl group. So a vinyl group. Let's look at another one that looks very similar to a vinyl group. So something like this coming off of your molecule will be called an allele. So this is an allele, and then on the left we have a vinyl group. So let's do an example that includes one of these substituents so we can see how to name it. So let's go like this. So how would we name this molecule? Well, once again, we look for our ring. So there are, let's see, 6 carbons in my ring. So it would be cyclohexane, but since there's a double bond present, we know it's cyclohexene. So let me go ahead and write cyclohexene here. Now we have to figure out how to number this guy. So I could make this carbon number 1 on my ring, or I could make this carbon number 1 on my ring. And I think with the experience we have so far, it's obvious that I want to make the top carbon number 1 to give my substituent the lowest number possible. So now I have my substituent having a being on carbon 1, and that of course is a vinyl group, right? So you can see there's a vinyl group coming off of carbon 1. So I can go ahead and finish naming it by saying 1-vinyl cyclohexene. Now when you have these 1s in here, and if you leave them out, they're implied. So you could say vinyl cyclohexene, and most people would assume that you mean carbon 1 for the double bond, for the start of the double bond, and for your substituent. So let's do one more example, and this time let's do an example that has 2 double bonds in it. So let's look at something like this, and let's go ahead and put a halogen in there too. So how would I name this molecule? Well, our steps are to find the carbon chain, right? Longest carbon chain that includes your double bonds, so that would be 4 carbons. Like that. So 4 carbons, our root for 4 carbons is bute. Okay, so we're going to go ahead and write bute here for 4 carbons. Now I have 2 double bonds in this molecule, and I need to figure out how to number my chain. I can start from the left or I can start from the right. And again, I think with the experience you have, you can pretty much figure out we're going to start from the left to make this carbon number 1, 2, 3, and 4. If I do it this way, you can see that the first double bond starts at 1 and the second double bond starts at 3, and the chlorine substituent comes off of carbon 2. If I chose the other way from the right, I would have the same numbers for the double bonds, right? The double bonds would be at 1 and 3 again, but I would have a number 3 for the chlorine substituent. So I think it's obvious that you want to start from the left here. So I have 2 double bonds at carbon 1 and carbon 3. So I have 2 double bonds. So how am I going to represent that? Well, I have 2 double bonds at 1 and 3. So I'm going to go like that. And two double bonds, our prefix for two was di, and our ending for an alkene is ene. So I have diene. So I have a diene here, and so let's go ahead and write diene. So I have diene, and just to make the name sound better, if you put a vowel in here, it just flows better. So we're going to put an A to get 1,3-butadiene. And then to finish off the name, we have our chlorine coming off of carbon 2. So for halogens, we're going to write 2-chloro like this. So it's chloro, bromo, fluoro, or iodo. So 2-chloro 1,3-butadiene is the correct name for this molecule.